let f of z is equal to u plus iv be the required analytic function. Okay, then one step what you have written in the previous question, one step you will write here. So I into f of z is equal to u minus iv. Therefore, directly 1 plus I into f of z is equal to p plus iq. You need not show it again. Okay, where p is u minus v and q is u plus v. Okay, up to this you have to write in each question. Then now here what is given, u plus v is given. Here also this u plus v is given. U plus v is given means q is given. Okay, so here this is equal to 1 plus I into, therefore 1 plus I into f dash of z is equal to px plus iqx, and that is equal to what we will write, since px is equal to qy and py equal to minus qx, means we are using CR equations. So px equal to qy. So see here q is given, u plus v is given, that is q is given. Therefore you will replace this px by qy. So qy plus iqx. Okay, now therefore now we will find this qx and qy. So all of you find out qx and qy. It's a bit lengthy one and very carefully you have to do it. So qx means the derivative of this with respect to x. So that is, which formula you need to use, write in the chat box. Which formula you will use? We need to find the derivative of q, derivative of this q. We need to find. Which formula you will use? U by v. Okay, very good. U by v formula you will use. I hope all of you know that. Okay, denominator into, so denominator cos h2y minus cos 2x, that is denominator into derivative of numerator, sin 2x derivative is cos 2x and then derivative of 2x is 2. So denominator into derivative of numerator, now minus numerator into, numerator means sin 2x into derivative of denominator. Derivative of denominator means what will come here, cos h2y constant, because we are doing it with respect to x. So cos h2y derivative is 0 minus cos 2x derivative is minus sin 2x and minus 2 will come. Okay, so sorry, it is derivative of cos 2x is minus sin 2x and derivative of 2x is 2 you will get. Okay, so 2 you will get there. Then that is equal to, and one more thing, is it completed the formula? No, because divided by what is there, denominator square is there. So now current, for time being I am writing it as dr square. Okay, we will write it later, denominator square. So now qx you got. Little simplification we will do here. That is equal to cos h2y minus cos 2x is there. So cos h2y minus cos 2x into cos 2x is there. So what I am going to do is, I am multiplying that cos 2x inside. Okay, since cos 2x I multiply here. So here first will be cos h2y into cos 2x minus cos 2x into cos 2x will be cos square 2x minus, now look at here, here minus, minus plus, plus into minus, minus you will get. So that is here 2 sine square 2x. Okay, understood? So here cos 2x into cos 2y is this. Cos 2x into cos 2x is cos square 2x. This 2 already we have taken here. And sin 2x into sin 2x is sin square 2x. Or here negative negative becomes positive, and that positive into this negative is negative. And this 2 is outside. And whole divided by denominator square. Okay. Then now this is equal to 2 into cos h2y into cos 2x minus, now look here, this is cos square 2x, this is sin square 2x. So here if I take 2, this 2 is taken inside, 2 cos square 2x minus 2 sin square 2x. Listen carefully, I am going to reduce a step here. This 2 is taken here, so 2 cos square 2x and this minus 2 sin square 2x. So in both these terms, what is there? Minus 2 is common. Okay, minus 2 is common. So what we can do? That minus 2 can be taken outside. So when you take minus 2 outside, this becomes 2 is outside and this becomes plus here. Am I clear? Write as no. Okay, so now this is equal to 2 cos h2y cos 2x minus 2 into cos square theta plus sin square theta is what? Right answer 1. So cos square 2x plus sin square 2x is 1. So 1 into 2 is 2 here, divided by the denominator square. Okay, so that is our qx. Now similarly qy we need to find. Qy means again denominator into derivative of numerator, and also that I will write here cos h2y denominator, that is cos h2y minus cos 2x into derivative of numerator. What is our numerator? Sin 2x. Sin 2x derivative is 0 because we are doing with respect to y. So denominator into derivative of numerator is 0. Now minus numerator. Numerator means sin 2x into derivative of denominator. Denominator is this one. Derivative of that means cos h2y. Derivative is 2 sin h2y. I hope all of you have studied the formula which I have given yesterday. Okay, so this is 2 sin h2y. Cos h2y. Cos h2y derivative is sin h2y. Sin h2y and derivative of 2y is 2. So like that it is 2 sin h2y. Then minus derivative of cos 2x will be 0, divided by here also the denominator square. Okay, so now that step is there. Cos h2y minus by denominator square. So denominator into derivative of numerator minus numerator into derivative of denominator upon denominator square. Then that is equal to, just simplify this. So here this into 0 means total this term is 0. Minus numerator here is 2 sin 2x into 2 sin h2y. So that we can write as 2 sin 2x sin 2 sin h2y. Sin h2y. divided by denominator square. Up to this, if you understood, write SS. SS no no. Yes. Okay. Now, so that is qx and qy. Therefore, 1 plus I into f dash of z is equal to, we have written at the top, we have written it as what? Qy plus I into qx. Okay. So, 1 plus I into f dash of z is equal to qy plus I into qx. So, that is equal to, you will write qy. What was our qy? Qy was minus 2 sine 2x sin h2y divided by this denominator square plus I into qx. Qx was 2 cos 2x cos h2y minus 2 whole divided by denominator square. Both denominators are same. Okay. So by denominator square, this is our qy plus iqx. Now here I am going to apply Milne-Thomson theorem. Okay. So by Milne-Thomson method, 1 plus I into f dash of z is equal to, what you have to do? Put x equal to z, y equal to 0 in both. So minus 2, see here, minus 2 sin 2z sin h 2y will come. So sin h 2y means sin h 0. Sin h 0 is 0. Okay, so I hope you remember semester 1 complex numbers it was there. Sin h 0 is 0. So here 2 sin 2z into sin h 0 will come, that is, that value is 0. So this total term, the first term completely, that will become 0. Okay, plus I into numerator here 2 cos 2z cos h 20 minus, so it is cos h2 into 0 minus this 2 divided by denominator. What was our denominator? Denominator was cos h y. Cos h y means cos h 0 minus cos 2z. This was the denominator. Look in your notebook. Cos hy minus cos 2x was the denominator. So I put cos hy is 0 minus cos 2x is z, the whole square. Okay. Now this is equal to I into, see, numerator you can have a 2 common. Okay. I into 2 cos 2z into, now cos h2 into 0 means it is cos h0. Cos h0 is 1 and sin h0 is 0. Okay, so this you need to remember. So cos h0 is 1, sin h0 is 0. So this cos h2 into 0 becomes cos h0 and that is 1. So this is 2 cos 2z into 1 minus 2 divided by, here again, 1 minus cos 2z the whole square. Okay, now this is equal to 2 is common and this I is common for both. So 2 is common, I into cos 2z minus 1 divided by 1 minus cos 2z the whole square. Now that is equal to, here 2I into, see, from numerator I am going to take a negative sign outside. So it becomes minus 1 minus cos 2z, because in the denominator you have 1 minus cos 2z. the whole square, or you can write this as this denominator as cos 2z minus 1 the whole square. No issue in that, because square, since square is here, you can write a minus b the whole square is equal to b minus a the whole square. Okay, because square is here, so it doesn't matter that sign. So that you can do. So, but I suggest you to take a negative sign from the numerator. So minus of 1 minus cos 2z, and denominator you got this. So as you know, you can cancel 1 term here. Okay, 1 minus cos 2z can be cancelled. So that is equal to 2i negative sign into 1 divided by 1 minus cos 2z. So now what is 1 minus cos 2z? 1 minus cos 2z is 2 sine square z by trigonometric ratio values. So that is minus 2i into 1 upon 2 sine square z. 2 gets cancelled. So that is minus I into 1 upon 1 upon sine square z. 1 upon sine theta, we know 1 upon sine theta is cosec theta. So this becomes here cosec square z. Okay. So here what was our left side? It is 1 plus I into f dash of z. Therefore, from here f dash of z is equal to, take this 1 plus I to the denominator. So minus I upon 1 plus I into cosec square z. Okay, this is an 8-mark question. So it's a bit lengthy. So now this is equal to f dash z is this one, so f of z you will get by integrating this one. But before integrating, what you have to do is, denominator, in denominator there is a complex term. So normally we do not keep complex terms in the denominator. We need to remove this one. So to remove that complex number from the denominator, what you have to do, write in the chat box what you have to do. To remove a complex number from the denominator, what you have to do? Write in the, we need to multiply with the conjugate of this denominator. Okay, so 1 plus I is there. Conjugate of 1 plus I is 1 minus I. Here also 1 minus I. Then again do not cancel this, you will get the question again. Okay, so into cosec square z. Then that is equal to minus I into 1 minus I. See the denominator a plus b into a minus b form. A plus b into a minus b is a square minus I square into cosec square z. That is equal to, take this negative inside, negative I inside. So minus 1 into I is minus I. Then here minus into minus becomes plus I square. Okay, so divided by 1, this 1 minus I square is minus 1 into cosec square z. Then that is equal to, now in the numerator here this is minus 1. Okay, minus 1. So you will get minus I minus 1 divided by denominator is 2 cosec square z. Or from the numerator, from here you can take a negative outside, so minus of 1 plus I divided by 2 into cosec square z. This was our f dash z. Okay, therefore f of z is equal to integral of f dash z dz, that is integral of minus, so this 1 by 2 into, this is a constant, so I am taking it outside. So 1 by 2 into 1 plus I, and integral of minus cosec square z dz. So write in the chat box what is the answer of integral of minus cosec square. Into integral of minus cosec square z is, what is that? Yeah, very good. Into cot z plus c. Hence, you got the answer.